Good morning, Troy. Got your box. We're gonna get you on the bench. We're gonna look at it together. We're gonna see what's going on. In your messages, you said that your door started acting up a week ago. You had me repair it last October. You took some voltage measurements. You said you hired a garage door tech to come out for 125 bucks. He said it was the board. He checked everything else and there's nothing that could be an issue but the board. He said he got the door to go up halfway on motor power, but then it stopped and now won't move at all. You were seeing the same behavior. And then you said the garage door people came back out again a second time and they said the transformer seemed warm. The transformer is always passing current as it is constantly plugged into your AC outlet. Once power enters the primary circuit of your transformer, it drops the voltage out of the secondary windings, in which then goes into bridge rectification, converts the AC into DC at around 24.5 volts. Then it's filtered and regulated down to about 5.5, and then there's other circuits energized by that as well. So the transformer is always going to be warm as it is always passing current. All right. Basically, the garage door people came out again, so the transformer was warm and the board was bad, but the transformers are always warm, period. All right, and I told you I'll be recording the process, so here we are. And here I could physically see that somebody has cut the end of this antenna. There is bare conductor here, which somebody has attempted to tie more wire onto it, which is bad. The reason it's bad is because you only have so much radio frequency output, right? So by adding more length of conductor, that increases impedance, which requires more power. So by increasing the impedance, you're actually reducing power. I know, that's how it works. So that's bad. That's right here. That's enough for me to void my warranty right now and not even look at this board. But I'm going to look at it because I'm quite confident that it works. Anyway, that's a big no-no. You don't want to do that unless you increase power output, and that requires replacing transistors, RF capacitors, and other things, resistors, allowing more power. So do not add wire length onto an antenna. Alright, serial looks good. It matches what's in my spreadsheet. I'm going to send you another warranty sheet, and you'll need to keep that inside the box so that way you have it for future repairs. You still got about another year left. First thing I'm going to do is use the meter to check the board, and this will tell me if it's good or bad. I don't need to put it on a test fixture to know if it's good or bad. Let's start with that transformer. Primary is spot on at 266 ohms. Secondary, perfect at 20 ohms. That is a perfectly measured transformer. That's a good transformer, nothing wrong with it. Let's look at the solder around it. No, I put a lot of solder on it when I repaired it, and it all looks good. There's no cold solder joints. All right, moving forward, let's test relay protections. That looks good. That looks good. And that looks good. So all your relays have good protection. None of them have shorted. Let's look at your drive transistors. All your relay drive transistors are good. Perfect condition. No problems with driving a door up or down because the transistors are good. And that also means that the op amp and processor are good. Let's check that processor right now. .8K at the filter cap on your processor. The processor is good. If I had ohms, it would be bad. The cap would be shorted as a result of processor failure. This processor is good. Let me look at the solder around it. Solder looks good on that processor. All right, moving on. Let's look at your output protection, which is something that could cause a door to do what you're describing. So let's look at the protection for your output sensors. Your protection so far seems good. Yeah, your output protection is fine. There is no problems with powering your sensors or receiving any sort of signal. According to my meter, this board should work. Let's look it over for other cold solder joints. I don't see any cold solder joints anywhere. I mean, when I refurbished this board, I resoldered all the spots that go bad, and I've been repairing these for over 10 years. And my full-time job is in electrical engineering, wireless product development. So I'm very good at fixing electronics, and especially boards that are receivers or transmitters. So, in my honest professional opinion, in all my years in working on electronics, this board should work when I plug it in. And let's see. I'm going to turn this light off, and I'm going to turn my overhead lamp off. When I plug the board in, a light should illuminate behind the unit. Light's illuminated. I'm plugging your sensors in right now. Alright, the first thing I'm going to do is hold the learn button down for 8 seconds until that amber LED goes out. This is a relearn. We're going to keep going. I'm going to do a hard reset. Holding it down again. 8 more seconds until the light goes out. Now I'm going to do this 3 more times now, for a total of 5 times. That's 3. That's 4 resets, and 5 will be the hard reset. Excellent. Turning the overhead lamp on. We're going to measure output voltages. This is going to also let me know if the board's good or bad. 23.1, that is very good. That's very good voltage right there. According to my spreadsheet, you had 18.76 volts when it came in here. So my repair is still looking good. All right, let's measure sensor output. You should have 5.8 to 6 volts. 5.8 volts. Output's good. That means your sensors are lit up, and they are. So everything should be working. Let's program a remote. My remote is 15 meters away. The remote programmed. Now it's working. One direction works. Triggering the remote from 15 meters away. It is on a wire. I removed the buttons from the remote, replaced them with wires, so that way I could trigger it from 15 meters away doing a range test. So here we go. And it works the other direction. Let's see if it completes a cycle. Alright, so we've completed 2 cycles. Doing it again. And again. So this board is functioning 100% as it should. Let's do a manual test wall switch. Manual's working. The manual switch is working. And it's no problems going up or down. The logic board is working as it should. Let's remove the sensor and give it a try. Alright, we're going up. Sensor has no function right now. Alright, we're going to go down. So we should protect because this sensor is disconnected. And we are protecting as we should because the sensor is disconnected. Now when I reconnect the sensor and hit the remote button, it should go down. And it does. Protection is working. Remote range from 15 meters is working. Manual wall switch is working. Let's have a look at that output power. I would like to see it right now at 21 volts. 23 volts. That's better than I wanted it. And again, my repair is working perfectly fine. The voltage is very high. And this tells me you have other issues on your end. Quite possibly misaligned sensors, bad RPM sensor, bad rollers on the door, a chain that has not been lubricated, or anything that causes resistance. These boards are current sense. So if any other mechanical portion of the door isn't working right, that's going to detect it and stop it. That's how it works. So I hope you understand that your board is working and that the garage door people you hired were wrong. You have other issues on your end that need to be addressed. Thank you very much and you have a great day. Oh, let's look at that serial number together so we know this is your board. There you go.